Okay, yes. Okay, today we are going to cover on the topics of integration. So integration is the reverse of differentiation. Everything in mathematics can be reversed. So let's take a quick look at this. How do we differentiate x squared plus 1? Answer is bring down the power minus 1. I'll explain to you why I keep saying this. Later you'll see the reason. Okay, now we differentiate another function. Bring down the power minus 1. Okay, next one. Bring down the power 2 minus 1 is 1. And the last one. So if I differentiate a function, 4 different functions, I get the same answer. So what happens if I do the reverse? So the reverse is given by the sign like this. Please take note, there's an integration sign and there's a dx at the back. Okay, this is the notation. So I'm going to integrate the reverse, right? What do you think is the answer? You definitely are correct. You get the x squared, right? But you get the answer. You write x squared, you only have half the answer only. So if I integrate this now, I only get x squared half. So how do I account for the plus 1, plus 2, plus 3, plus 4? Every value in a mathematical equation or function is important. Seriously. Even if it's just 0.001 is important. So how do I account for it? The constant, right? So yes, very good. So we have to account for the constants. We call it plus c. Now, it doesn't matter whether the constant is a positive or negative. We just put plus c, whereby c can be positive and c can be negative. So now, what is the process of integration? So you know it's a reverse. So when you do things in reverse, it's like that. So if you times, you got to divide. If you square root, you got to square. But what you do first, now you do last. What you did last, so you do first. Okay, what do I mean now? Now let's look at differentiation. The instruction was, for differentiation, you always say bring down the power minus 1, right? I hope you all say that every time. So we always bring down the power. So when I bring down the power, what am I doing? What operation is it doing? Yeah, this is a multiplication, right? So bring down the power is actually multiplication. Okay? And then power minus 1. Okay, then you have power minus 1. So far, agree? Bring down the power is actually a multiplication of the power, and then you power minus 1. Now let's do the reverse for integration. So without me teaching you, what do you think I should do first? Okay, again, whatever you do first, you do last. Whatever you do last, you become first. Yeah, so I should have power plus 1, right? I should... first in, last out, It's all right. Last in, first out, Makes sense, right? You go inside the leaf, right? The last person come in, first person go out, right? So it's a logical thing in life, okay? Last in, first out, first in, last out. So this is the last thing I did for differentiation. So this should be the first thing I do for integration. After that, I add the power, add 1 already. What must I do? I should do a division. Okay? So in order to integrate this, I need to power plus 1, and then I need to divide. Divide by how much? Okay, I don't stress you. You just divide by the new power. Okay? Okay, what is wrong here? You just mentioned this, moments ago. Yes, correct. You have to plus a c. So same thing here. What do you think? A, x, I add the power plus 1, right? And then I divide by the new power. Say plus c. Okay, it's good that you always just say it out. Okay, now this one, the power is 0, right? X power is 0. A is a constant by the way. So if I integrate a constant, A, not to the, AX, divide by 1. So when you integrate a constant, you just need to add the x behind. That's what you will be telling yourself in a while. Every time I integrate a constant, I just add the x behind. What is missing? Please say this out all the time. Okay, the last one. You always bring down the power minus 1, right? And then multiply by this. Okay, now let's think of the reverse. Again, we always bring down the power minus 1, and then we have to still multiply by this for differentiation. So integration, let's do a reverse. What do I do? Do this. The power plus 1 divided by the new power. Okay, so in differentiation, what do I do here? I times the a, right? So integration, I should divide by the a. Okay, what is missing? All right, so I'm going to show you some examples. Very, very simple one, really very simple. Okay, the first question will be integrate this. Come, let's do together. What must I do first? If it's unfamiliar, I will rewrite this as x power half. Okay, next, and let's answer this. What's the answer? X 3/2. Then you divide by 3/2, right? Do you know when you divide by 3/2, it will become 2/3. Okay, what is missing? Plus c. Okay, let's continue with the next example. What did I just mention? Can you integrate a function like this? Cannot. The bracket inside must be only linear. So this one cannot. I got to convert. What must I do first? What must I do first? Expand and simplify. So let's quickly expand. I get x cubed. I get x squared. I get 2x. And I get 2. Okay. So say out. The first answer is x to the power of 4. Hey, wait. The power plus 1. And then you divide by the new power. Okay, I write over 4 because you all must be confused if I write 1/4. Add 1 to the power. Divide by the new power. Okay, then the other one. Add 1 to the power. Divide by the new power. Please say this out all the time. Divide by the new power. The important word is new power. The new one. Okay, next one. 2x squared divided by 2. Okay, the last 2 is the most important one. Plus, when you integrate a constant, you just add the x behind. Are we done? You have to plus a c. This one you must simplify. I think I may have written in some of your homework. Some of you don't simplify fully. But most of the time you do. Okay, and that's how we integrate a simple polynomial. Okay, so let's simplify this. Okay, let's simplify this. You get 2. Okay, usually for me as a student, I don't like to write so many steps. So here I will straight away write x to the power of -2. Easier for me to integrate later, so I usually do this. And please remember to put the dx. 2x minus 3x to the power of -1. Yes, plus c. So let's say we forgot, purposely forget one. So I write like that. Oh, then I remember, plus c. So I will do this plus c, and I'll track back all the way until There's no integration sign. I just put plus c all the way up. Okay, last one. Inside is a linear form, right? Look at the bracket. The bracket inside is linear, so yes, we can integrate. Okay? How do we integrate this? Last example already? Change, yeah, correct. I want to hear the word change. Change to what? Change what?
Bracket 1 minus 2x.
Bracket 1 minus 2x to the power of -5 dx, and we are now doing this last example here. Okay, let's try. What's the power? The power now becomes -4. Step 1 done. Step 2, divide by the new power. Step 3, -2. Okay, -2, right? And then plus c. Okay, so we will have 1 minus 2x to the power of -4. This is over 8, right? So I write 1 over 8 here, plus c. Okay, so the question is, why must I divide by the a here? That was Jimmy's question, right? Why must I divide by the a here? 4 lah, okay? Let's integrate this. We will have 1 plus 3x power 5 divided by the new power times 3, right? So then we plus c. So we get 1 over 15, 1 plus 3x power 5 plus c. Okay, so the Jimmy question was, why must we do this? Okay, if we never do this, see what happens. My answer will be 1 over 5, 1 plus 3x power 5 plus c. Purposely never divide by 3 one. So now let's differentiate. Bring down the power. Bring down the power. Power minus 1. Then you still need to times this, right? When you differentiate. So when you times this, but look at my original one, don't have, right? I need to divide away the 3. So in my process, I need to divide away the a. Otherwise, there will be an extra a, because you remember, I bring down the power minus 1, differentiate the inside. So when you differentiate the inside, you are multiplying, right? So you need to divide it away. All right, so that's all for the video. Thank you.
Oh, must say, Jacob, you stop the video.